Hello, hi, welcome. This is Dr. Hadi here, and you are watching Medical Globe. Today's topic is from biochemistry, that is physical properties of amino acid. There are 7 physical properties of amino acids right on the whiteboard that we will discuss today. Among these, 4 are very important that most of students ask me to record a video on that. That is the amino acid as ampholites, optical properties of amino acids, Zwitterion, and isoelectric pH, most important. We will discuss this in detail, but before we discuss this, there are 3 easy physical properties that we will discuss them orally, and there will be no need to write them on the whiteboard. The first one is the solubility. Amino acids are soluble in water, they are not soluble in organic solvents. First, taste. Some amino acids are sweet, others are tasteless, and others have bitter taste. You can write the name of those amino acids which have a sweet taste. They are glycine and alanine and valine. These are the 4 amino acids. And now the one which is tasteless is the leucine, and the one which is bitter in taste is the arginine. So arginine is bitter in taste, leucine tasteless, these 3 are sweet in taste. The melting point of most of the amino acids is very high, that is about 200 degrees centigrade. Now come to the most important, that is amino acid as ampholites. What does it mean by ampholites? Mean if a molecule exists itself both as an acidic as well as a base, we will call that molecule as an ampholite. How? As you know the structure of amino acid very well, that an amino acid has an alpha carbon, a central carbon. To its right and left there will be 2 functional group. One is COOH, carboxylic group, and amino group NH2. There will be a hydrogen and a variable group R. This is the general structure of the amino acid, and today we will discuss these 2 groups. Our whole lecture will be around these 2 groups only, so there is no need to focus R because we have already discussed R in the initial topics of this protein chapter. So this is an amino acid. If you see, this is a kind of free amino acid. You know that you can't see any charge on that amino acid. That is now free amino acid. In reality, none of the amino acid in our body is found in that free state. All amino acids are having some sort of charge. I mean, they are in the form of charge. Either some amino acids are negatively charged, other are positively charged. Now, what is the factor that determines that amino acid has a positive or negative charge? Which factor? That is the pH. That is the pH. We know very well with this term pH. The negative log of hydrogen ion concentration is called as pH. pH is from 0 to 14, and there will be 7 in the middle. From 0 to 7 or before 7, there will be acidic pH, and from 7 to 14 there will be basic pH, or you can also call it alkaline pH, right? So there will be, of course, number 8, 9, 10, 14, 0 to 6. Now what will happen to an amino acid when we change the pH from acidic to basic or from basic to acidic? Now let's start. The first case is 8 high pH. Let's suppose the first case 8 high pH. That's what I'm going to write here. 8 high pH. What will happen 8 high pH? First of all, what is mean by high pH? High pH means basic pH, or alkaline pH. Things around the world are either basic or acidic. So how you will decide that it is basic or acidic? That is the pH. If the pH is high, means above 7, they will be called basic or alkaline. So what will happen to an amino acid 8 high pH? 8 high pH, remember, there will be less protons, less hydrogen ion available. So now what will happen? When protons are less, means the condition is alkaline, the condition is basic, that amino acid will act as an acid. That amino acid will act as an acid. I will also write amino acid will act as an acid. When the pH is high. So now what will happen? You know very well that an acidic compound receive proton. Acidic compound receive proton. Donates proton, sorry. Basic compounds receive proton. Acidic compound donates proton. So now if the amino acid act as an acidic, what it will do? It will release a proton. So you can see one hydrogen is here and another hydrogen is here. So this amino acid will release one of its hydrogen ion in the form of proton. So which one is? That is the carboxylic group. This carboxylic group will release its hydrogen, and as a result the structure will become like this. After it release the proton, the structure will become like this: carbon COO minus, because hydrogen has been released, and NH2. Nothing will happen to this amino group. There is H and R. Overall, the amino acid acquired a negative charge. Now the amino acid become negatively charged. So it is now so easy to say that which time an amino acid gets a negative charge, we will say 8 basic pH. 8 alkaline medium, the amino acid acquire negative charge. This is fine. Now the second condition, the second category. Second category is if it is here we have a high pH. So here we will say that what will happen to that amino acid at low pH. Low pH, what is mean by low pH? Low pH means 65321. 65321 mean at this condition the medium is said to be acidic. Here the medium was said to be alkaline, but here the medium is said to be acidic. In acidic medium, if you place this amino acid in acidic medium, the amino acid will act as a base. Now what I will write here, in this condition the amino acid will act as a base. And what a base does? A base receives a proton, a hydrogen ion. A base donates electron pair also, but a base receives proton. Now what will happen? That amino acid will receive a proton. Here is H. This will be enough to say. And because at low pH the hydrogen ions are in excess. I also write, because here at less pH sorry, at high pH the hydrogen ions are less. But remember, at low pH, the hydrogen ions are in excess, mean more in excess. They are in excess. Most of students get confused. Low pH, they think that at low pH the hydrogen ions are less. No, this is wrong. At low pH the hydrogen ions are in excess. At high pH the hydrogen ions are less. So when hydrogen ions are in less amount, now what will happen? That amino acid will release its hydrogen ion. It will get a proton. Now, in order to get a proton, that amino acid, which group will get a proton? In that case, we came to know that which group will release proton. Now, which group? Either this group will get a proton or this one. It is not possible for COOH to get one more hydrogen. It is not possible. So we will exclude the carboxylic group. The carboxylic group has no function, has no value in case of the acidic pH. In case of acidic pH, the duty will shift or transfer to that amino group. That amino group has the capability to get a proton, to get a hydrogen ion, a proton from the surrounding medium. What will happen? That amino acid will become like this. That is carbon, and here we have COOH. There is hydrogen, there is R and NH. Two hydrogen atoms are already present. The third hydrogen atom, when comes, that will make it as NH3 rather than NH2. NH3 will get a positive charge because nitrogen can make 3 bonds in normal solution. When the nitrogen make 4 bonds, then it will acquire a positive charge. Now, in this condition, we got the amino acid as a positively charged ion. So every amino acid can either have a positive charge or negative charge. Depends upon what? Depends upon the pH. Right? We got it. Now, for this reason, as we came to know, we conclude now that because an amino acid can behave as an acid as well as a base, means an amino acid can release a proton, become an acid, or get a proton, become a base. For this reason, we will call amino acid as amphfolite. We saw that, amphfolite. So the first property has gone, amino acid as an amphfolite. The second one is Zwitterion. What is mean by the word Zwitterion? The word Zwitterion means when amino acid get a positive charge as well as a negative charge, both. Look at this. If you see here, the amino acid has positive charge only, in here negative charge. A condition will also come sometime that an amino acid get both positive and negative charge. Means, if I give you the example of this, let's suppose if there is a negative charge and there is a positive charge, both, this kind of amino acid will be called as Zwitterion. Zwitterion is a German word, means for hybrid, both negatively charged and positively charged. Now there's a question arises in the mind of students: is it possible for an amino acid to acquire both charges? Yes. An amino acid can acquire both charges, but for this purpose, you have to provide a specific pH. You have to provide a specific pH. That specific pH will make the amino acid in Zwitterion. Different amino acids have different specific pH to become Zwitterion. For example, the leucine. If I give you an example of leucine, leucine is a very well-known amino acid. Leucine can get both positive as well as negative charge. Leucine can become a Zwitterion 8, which pH equal to 6.0. Means leucine can acquire at a positive as well as negative charge if the pH is 6.0. Now, what will happen to the leucine above this pH or below this pH? So what will happen? If you change the pH either above that 6.0 or below that 6.0, then your amino acid will get any one of the two charge. Mean amino acid will be either a positive or a negative, as we discussed here. So above or below that pH, the amino acid will become either a positively charged only or negatively charged only. But if the pH is exactly 6.0, it will get both positive and negative charge. There are other amino acids that also have this kind of pH. So what is the name of that pH, that specific pH at which an amino acid shows both positive and negative charge? The name of that specific pH is called as Isoelectric pH. It is called as Isoelectric pH. That's a very special name. So how to define isoelectric pH? That pH at which the amino acid acquire both positive and negative charge, and also at that pH the amino acid will be overall neutral. The amino acid will be overall neutral. Why? Because the positive charge will cancel the negative charge. For this reason, the overall amino acid will be considered as a neutral. So we got the definition and concept of isoelectric pH as well. So Zwitterion has gone, isoelectric pH has also gone. Now the last one is the optical properties of the amino acid. Let me tell you something about optical properties of amino acids. We have discussed this topic of optical isomerism in the chapter of carbohydrate with very detail. Once again, optical properties mean if a molecule contains such an atom at which 4 different groups are attached. Let's suppose if here A, B, C, D. If 4 different groups are attached to a central atom, we call this molecule what? Asymmetric. Asymmetric. And if it is carbon and around the carbon there are 4 different groups, so we will call asymmetric carbon. We will call it asymmetric carbon. Those compounds, whether carbohydrate or amino acid or protein, whatever, those compounds which contain an asymmetric carbon, they show optical isomerism, means D and L form. D and L form. The D and L form of isomers are made with comparison of glyceraldehyde. In glyceraldehyde, if you see glycerol, there are 3 carbon atoms. The last carbon atom CH2OH, and here H and OH. There is C double bond O and H. If you see here, this carbon is an asymmetric carbon, and watch it, look at this carbon. Around this carbon you can see 4 different groups. OH is different, H is different, this whole group is different, and this whole group is different. So around carbon we have 4 different groups. So this is an optical isomer. It contains asymmetric carbon. Now if the OH is on the right side, it will be called as diglyceraldehyde, and if the this OH is on the left side, it will be called as N-glyceraldehyde. All other compounds can also be named according to this glyceraldehyde. In any other molecule, you will have to see the OH. If the OH in that molecule is on the right, so you will call it the D amino acid. Let's suppose you have an amino acid, and you know, in amino acid there is you can find an asymmetric carbon in amino acid, and I will write here, if this is carbon COOH, here is NH2, and here is hydrogen, and there what you can see here, a variable group R. So if you see around the carbon, you can see there are 4 different groups are there. So yes, we say that the asymmetric carbon is present, so the amino acid can also act as a optical isomer. It can show optical isomerism. So as you know, optical isomers are D and L sugar, so in this case D and L amino acids. So now we see, except glycine amino acid, which does not have asymmetric carbon, because in glycine you can see there are 2 hydrogen atoms at the top and bottom, so similar groups came, it does not contain asymmetric carbon. So excluding the glycine, all other amino acids have 1 or more asymmetric carbon, so therefore all other amino acids are said to be having this optical isomerism. So some of the amino acids may be D amino acid or L amino acid. D and L amino acid are named according to that glyceraldehyde. For this reason we name the glyceraldehyde as a reference sugar, because we compare other molecule with this glyceraldehyde. Glyceraldehyde is actually a carbohydrate, a monosaccharide. So we've got the physical properties of amino acids in today's lecture. I hope you enjoyed watching that video, and also thanks for watching my video. If you understand, if you got that lecture, please give us a like and also subscribe. Also share this video with your fellows. Thank you very much.